So, we meet again, and today we will be talking about air jet texturing, of course, but the effect of application of water. This is the main theme of today's lecture. A step back, till now we have learnt the effect of overfeed on instability and bulk generated, effect of pressure on instability and bulk generated, how the hot water shrinkage gets affected by the bulk generated, effect of the above two parameters on tensile properties, and also effect of heat setting on the properties of air jet textured yarns. Again we recall as to why shrinkage gets affected by the bulk. As we mentioned before, higher bulk means less entanglement. That means the fibers are not making so much of a contact with each other, and if there is a fiber, let us say polyester in a hot water, an individual fiber wants to shrink, then the fiber next to it or the filament next to it may not follow the same path. It may shrink on its own, but it may not follow the same path, would not force the other filaments to go along with it, and therefore, you may find that high bulk may not lead to high shrinkage. The shrinkage may be reduced. If the bulk increases, then shrinkage can get reduced, because the structure becomes loose. So, if a tighter construction is there, single filament shrinkage would mean all the filaments must follow which are in contact with that fiber. They of course, will shrink themselves as well. So, that is how the bulk affects the shrinkage in the case of synthetic fibers, hot water shrinkage, because the fibers or filaments want to shrink. Effect of heat setting, that is, you have done, let us say, the mechanical stretching has been done. So, certain amount of instability has been obtained, but if it is a thermoplastic fiber or filament yarn, then you can do the heat setting. So, what happens the heat setting to the instability? The instability will go down. It will go down because the entanglements will become tighter as a result of shrinkage, and so instability goes down. What will happen to the bulk? The bulk can also go down because the loop size is going to decrease. Also, the number of loops also will decrease, because some of them may get merged with the body of the yarn because of shrinkage due to heat setting. This is obviously for the thermoplastic yarn. So, what we have learnt is that the overfeed is one of the major parameters which affects properties, and so we optimize that, and air pressure is the second important parameter which also affects all the properties. Of late, people have started applying a certain amount of water, which is a clumsy process, I would say, because normally a texturing is a dry process and you want to add water to this. So, it can't be a good process. Nevertheless, you would do such process only if it helps you. So, application of water is what we are going to be talking about today, right. Effect of water application, all right. How does it improve or affect the quality? So, as mentioned, we will talk about two things, that is, what is the effect of the quality of air jet textured yarns if we have a certain amount of water applied to the yarn, or effect on instability. This is instability for us is the most important parameters. So, water application. How do we do the water application? There is attachment, we can call it a applicator or a water applicator. This is an attachment which is placed before the actual jet. So, this applicator may look like this. So, it is like a hollow vessel which is sealed completely. The water obviously is allowed to go through nozzle into a hollow chamber, and this chamber has got some orifices through which the water will ooze out. The yarn would pass through like this and pick up water as it is passing through, and so will get wet, and after that it will pass through the so called air jet. So, this is a pre-wetting which is allowed, which is used. The question that comes, is there a control? Do you want it to be controlled? How much water do you want to apply? What do you think? How much water would like to apply? It has to be very small amount. Therefore, it is metered, that you exactly know how much water is coming out based on the speed of the yarn at which it is moving over the applicator. So, it is a metered amount. You have a control. So, you can apply more or less, but how much more? Just enough to make a thin layer on the surface of the filaments. You definitely do not want that the water be dripping. So, the quantity of water which will be required will be based on the surface. Finer filaments may require maybe more because they have more surface, coarser filament will require less because they have less surface, but obviously it should not be dripping. Why all this thing came into picture? People wanted to see what happens to inter yarn friction when you, let us say, apply water. So, yarn gets wet, it has a certain layer of water film. So, a good number of researchers did some experiments. All this work was done on polyester yarn which was texturized, air jet texturized. And what did you observe? They measured the inter yarn friction. So, there was some understanding as to inter yarn friction would play some role on wetting. Why? Because this layer will be something where there is a inter fiber layer which between the two fibers there is a hydrodynamic layer, and where shear can be there between the two filaments, and so it will be important that it can reduce the fiber or it can reduce the friction, it can reduce the friction. Will it be helpful? So, yes, it was helpful. What was helpful? Wetting. What happened to the instability? The instability reduced after wetting, and so it was assumed that the inter yarn friction is reduced because of the thin film of water between the filaments, and it was helpful because instability was reduced. An interesting hypothesis also was there that when inside the jet the friction would be less, because yarn are touching, yarn may have to move relative to each other, and because there is a water film, the friction would be less. And when it exits the jet, the water will get removed from the surface and would get in a way sprayed outside the jet, which could be obviously there is collected and drained off. So, there is a chamber in which a wetting device is kept. And so, the textured yarn is more or less dry. So, inside the jet you had less friction, outside that jet it is more or less dry. So, if the friction was the cause, the friction would be more now, which is good for entanglement, no slippages will take place of the loops, and one can feel good. That is what it means. That is, you can get less instability. The same experiments were then repeated on various other yarns like viscose and nylon. And the hypothesis was that because the friction will be there reduced, and so it will help. What did we see? They found instability of the textured yarn goes down. So, it is an advantage in these cases also. Then they measured the inter-yarn friction. So, when they measured the inter-yarn friction, it was found that actually it was more even on nylon filament yarns, and the friction, inter-fiber friction, inter-yarn friction was much more, still more in the case of viscose filament yarns. Now, suddenly we have confusion. Why did the friction, inter-yarn friction increase instead of decreasing? Because these fibers, viscose definitely and nylon relatively is more hydrophilic. So, it makes hydrogen bonds with the water molecules, and so the shear and the slip is reduced. So, confusion was obviously there as to whether what is the role of water then. So, role of water became an interesting question. While these experiments were going on, people wanted to know, is anything happening to the tension in the yarn? Which tension? We are talking about, let us say, this is the jet, and the yarn comes out, and there was an overfeed. This overfeed has been consumed because of the interaction, let us say, with the air or compressed air, and air yarn, which was a parallel bundle of multifilament yarn, now is entangled textured yarn and goes out. So, you measure the tension here. Will the tension be 0 because of the overfeed? No, because the overfeed has been consumed. So, there is a tension. Now, this tension would depend on what is the air pressure, what is the speed of the take up roll, which means the overfeed, and so there is tension. So, not having a tension would mean that it is going to become loose. That is not something which you would like. So, tension is there. So, you measure the tension. What was interesting was that irrespective of the nature of the yarn, polyester, viscose, nylon or any other yarn that you may like to use, the tension increased on wetting. Let us say we plot versus tension. Obviously, we are talking about the at the exit. So, if you plot this, you get a curve like this. In the case of a dry texturing, when you wet and do the experiment, people found you get a curve similar, but the tension was more, there was a tension difference. So, irrespective of whether it is a viscose, polyester, nylon, the wet texturing resulted in higher tension at a given overfeed. So, what do you think? Why is the tension high? You need more time to think? Your response? Okay. Let us ask this question. Will the humidity in the air increase or decrease? What have we done? We have done, there is this air jet, and then there is this wetting device, so air first goes here, then goes there, and then we hope the textured yarn comes out. So, we are talking, and of course, compressed air is coming from here. And of course, in between these two we have given overfeed. So, yarn is going to be pulled, right. So, it is wet, only thing is now it is wet yarn. So, the humidity which is here in this area, will it decrease or increase? Obviously, humidity of the air is likely to increase, because some of the water which is on the surface may get sprayed into the air as it is moving, because the air is under pressure, velocity of the air will be quite high in the jet, and so this is what will happen. And of course, we said at the end exit, some air, water may actually be sprayed out also. That means, there is some moisture is going to be added to the air which is being pushed inside. So, humidity would increase. If the humidity increases, humidity of the air inside the jet has increased. As a result, what would happen to the drag force which is being applied to the yarn which is moving through the jet? After all, yarn is overfed and it is actually going to be moving because something is pulling. If nothing is pulling, then it would just get collected. So, something is pulling. So, that is the drag force because of the air pressure that we have and the motion of the air. Now, humidity is more. If the humidity is more, will the drag force be high or less? The drag force will be high. Now, then the yarn is also moving with some velocity. So, there is another term which we may like to talk about as the momentum of the yarn. So, momentum depends on the mass and the velocity. Right. So, will the mass improve? The mass of the yarn which is moving because of the flow of the air, it will be more than that of the dry yarn, because some water is still going to be sticking around. and velocity is whatever. It may also increase more because the drag force was more, and therefore, the momentum will be more. So, the momentum of the yarn would increase and not decrease. So, what happens? The drag force is high, the mass of the yarn, and so the momentum is high. Result, the tension in the yarn at the exit will be high. Why would the tension be high? Why would the tension be high? It is moving and momentum is high. Why is the tension high? The tension is going to be high because it is being pulled faster with a higher momentum. So, what is happening at the exit now? So, filaments are coming, they are being pushed because of the drag, and because momentum is also high, there is only limited amount of excess yarn. And it is going to be pulled, and if it is going to be pulled higher, the tension would be higher. Higher is the tension at the exit. It is like, think about that we were saying that you put mechanical stabilization by pulling. So, there are loops which are going to be generated and the tension is high. So, what will happen? The loops will become more tighter, the entanglements become more tighter, and so instability would increase. So, by adding some amount of water, we have achieved a tighter entanglement, low instability, and so better product. So, the effect of wetting on friction is different, but the output is the same. It is because of higher momentum and increased tension, all right, and that is how the quality of the textured yarn has been increased, less instability and better quality. So, a little bit of a confusion, whatever it was on the friction, what it does to the air jet textured yarns, other than what we were looking at water. Maybe you can change the friction, interfiber, inter-yarn friction, filament friction by adding different kind of spin finishes, different amounts of spin finishes. So, some research work has been done on those things also. We may not cover in this lecture, but you can go through various research work done on various fibers and see what effects that they have. Thank you.